Lesson 2 of Chapter 0 is on operations with complex numbers. First objective we're going to be focused on is performing operations with pure imaginary numbers and with complex numbers. So we need to talk about the imaginary unit I. And up until Algebra 2, you've kind of been taught that you can never take the square root of a negative number. Yet there's times in mathematics when you end up with a negative inside of a square root. So you need a tool to be able to handle that situation. And thus, you've learned about the imaginary unit, I. I is equal to the square root of negative 1. So that allows you to work with negatives inside of square roots. For instance, if I were to give you the square root of negative 4, that could be broken down into the square root of 4 times the square root of negative 1, which could be broken down further into 2i. Okay, so the square root of negative 4 simplifies into 2i. If we did another example that wasn't the perfect square, such as the square root of negative 12, we would break that down into the square root of 4 times the square root of 3 times the square root of negative 1, which would end up giving us 2 with a square root of 3. And I like to put the I in front of the square root like that. You could put the I behind the square root, but then sometimes it gets perceived as being inside the square root. So that's why I like to put it in front of the square root. So these are the imaginary units. And so just to make sure we understand, the imaginary units are cyclical, which means that they cycle every 4. So we talked about I is equal to the square root of negative 1, which means I squared would be equal to negative 1. And it means I to the third would be equal to negative 1i. And I to the fourth would be equal to positive 1. And so then after that, it cycles. We got I to the fifth would be the same thing as I to the first. We got I to the sixth, which would be the same thing as I to the second, or negative 1. I to the seventh would be the same thing as I to the third, or negative I. And I to the eighth would be the same thing as I to the fourth, which is 1. And again, it keeps cycling. I to the 9th, 10th, 11th, 12th, you can see, are equal to the same thing. So hopefully this shows you how it cycles every 4 units with the imaginary unit. So example 1 says to simplify I to the 53rd. We have 2 different ways we can do this. The first method I want to show you is to take the exponent 53 and divide by 4, because it's the imaginary unit cycle every 4. And this would give us 13 with a remainder of 1. So then what you do is you just take that remainder, and that becomes your new exponent. So I to the 53rd is equivalent to I to the first. And that's simplified. A different method of showing you how to do the same thing here is I'm going to rewrite this as I to the fourth to the 13th power, and then I'm going to have to multiply that by I to the first, because 4 times 13 gives you 52. And if you use properties of exponents and add an additional exponent, that gives you 53 total. And so I to the fourth is equal to 1, and 1 to the 13th power is just 1. So this ends up simplifying down into 1i, which is the same thing as what we had in the previous method, I to the first. Example 1, part B, has same kind of problem, but this time our exponent is negative. So if we took the negative 18 and we divided by 4, that would give us negative 5 with a remainder of positive 2. Because what is negative 5 times positive 4? It's equal to negative 20. And so we have a positive 2 remainder. And so I to the negative 18th is equivalent to I to the second, which simplifies down into 1. Similarly, using a different method, we could rewrite this as I to the fourth to the negative fifth times I to the second, because 4 times negative 5 is negative 20. This becomes 1 to the negative 5 times I to the second. So this becomes 1 times negative 1, which gives us negative 1. And I made a mistake over here in method 1. I of the second is equal to negative 1, and I accidentally wrote that it was equal to positive 1. So example 2, we're going to take two complex numbers and add them. So a complex number is written in the form a plus bi. It's got a real number part to it, the a. It's got an imaginary number part, the bi. So here's two examples of adding and subtracting complex numbers. You can see here's the first complex number, here's the second complex number. If you're going to add these together, you just add the real number parts. So 5 and negative 2 gives you a 3. Add the imaginary number parts, negative 3i and positive 4i gives you positive 1i, and there's your new complex number. Part B is done the same way, except for now we're subtracting. So if we're going to subtract those, we're going to say 10 minus 14 gives us a negative 4. And if we do negative 2i minus a negative 6i, that becomes a double negative right there. And so that becomes negative 2i plus 6i, which gives us a positive 4i. Now I did that, mentally. Some people like to take a subtraction problem, such as this one, part B, and just rewrite the problem as an addition problem. So I'm going to change that minus sign to a plus sign, as you can see. But then I have to change my second complex number from 14 minus 6i into negative 14 plus 6i. Now this problem gets done just like part A. So if you combine your real number parts, then combine your imaginary number parts, you end up getting the same result. Last thing on this video is to talk about multiplying two complex numbers. Well, here we have two complex numbers, and if we're going to multiply those, we need to use the FOIL method. If you don't remember what the FOIL method is, the F stands for multiplying the first terms, 2 times 7. The O stands for multiplying the outside terms, 2 times negative 4i. The I stands for multiplying the inside terms, negative 21i. And then the L stands for multiplying the last terms, which gives us 12i squared. Now we need to simplify this expression. And going back to the I squared, since I squared is equal to negative 1, this term at the end simply simplifies into negative 12. Still got the 14. We can combine the middle two terms because they're like terms to get a minus 29i. And now combining the constant terms, we end up with a result of 2 minus 29i. And there's your new complex number after multiplying the two. We'll have some examples here, just like I went through, of simplifying complex numbers, and then also adding and subtracting and multiplying complex numbers.